Right now, a visitor from the stars is hurtling toward us at a speed of 45 kilometers per second. It has traveled through interstellar space for millions of years, and we have only 9 days to truly encounter it.
Hello everyone! Today, we will follow the journey of one of the most extraordinary objects currently approaching Earth, 3I/Atlas. This video will be longer than usual, because this story is far too amazing to be told in haste. On July 1st, 2025, astronomers detected a strange point of light moving through the constellation Leo. But what made them jump out of their seats wasn't its brightness, it was its trajectory. After just a few hours of calculations, the numbers started to not add up. The path of this object was not closed like an asteroid's. Nor did it curve like a familiar comet. Instead, its trajectory was wide open, steep, and irreversible, a hyperbolic orbit. What does a hyperbolic orbit mean? It means this object is not bound by the sun's gravity. It came from outside, and it will leave forever. As data continued to pour in from telescopes around the world, silence fell over the control rooms. No one said it out loud, but everyone understood. We were witnessing an interstellar visitor. It was named 3I/Atlas. A solitary traveler, it wandered millions, perhaps billions of years in interstellar space before unexpectedly crossing our star system. It didn't turn, it didn't stop, it just glided past. 3I/Atlas is the third interstellar object ever discovered by humans. The first was Oumuamua in 2017, a strange cigar-shaped object that sparked countless debates. The second was 2I Borisov in 2019, an active comet with a brilliantly glowing tail. And 3I/Atlas is an entirely different mystery. Imagine finding a bottle washed up on a beach. But the bottle came from a continent no one has ever set foot on. Atlas is just like that, a sample from another star system, carrying information about where it was born. And right now, we will follow its journey as it travels through the solar system in the most intuitive way possible. On December 10, 2025, 3I/Atlas was located in the constellation Leo, south of the star Regulus. At that time, it was about 2 AU from Earth, twice the distance between the Earth and the Sun, with an apparent brightness of around magnitude 17. Far too faint to be seen with ordinary telescopes. Only professional observatories were capable of detecting it. From December 11 to 15, 3I Atlas accelerated, sweeping across the constellations Sextans and Leo Minor. As the gravitational influence of the Sun and Earth became increasingly significant. By December 17 and 18, the distance had decreased noticeably, and its brightness increased to around magnitude 16. This marked the most critical window for observatories to collect detailed data. And then, on December 19, 2025, 3I Atlas made its closest approach to Earth. At a distance of about 0.25 to 0.35 AU, equivalent to roughly 37 to 52 million kilometers. Still about 1.5 times farther than the orbit of Venus.
So the most important question many people are worried about is, will it collide with Earth? The answer is very clear and definitive: no. There is absolutely no risk of collision. 3I Atlas is merely passing by along a precisely calculated trajectory. It is far enough to be completely safe, yet close enough for humanity's most powerful telescopes to study in detail a visitor from another star system. So after December 19, where will 3I/Atlas go? Below is the trajectory we predict it will continue to follow. From December 20 to 31, 2025, 3I/Atlas begins to leave the constellation Leo and move toward Virgo. Its distance from Earth increases rapidly, its brightness fades significantly, and its apparent motion slows as it escapes the Sun's strongest gravitational influence. Observing it during this period becomes far more challenging.
As we move into early 2026, 3I/Atlas continues across Coma Berenices and heads toward Boötes. At this stage, it nearly disappears from ordinary observational capability. Only the largest telescopes at professional observatories may still have a chance to detect its extremely faint signal.
By March 2026 and beyond, 3I/Atlas disappears completely from human observation. It leaves the solar system, drifting onward into the cold interstellar space, where there are no landmarks, no lights, and no observers. And we will never encounter it again.
A natural question arises: how can we observe 3I Atlas? The first thing to make clear is that 3I over Atlas cannot be seen with the naked eye. Its brightness is only around magnitude 16 to 18, far too faint for human vision, even under a perfectly dark night sky.
To observe 3I ATS directly, a large telescope is required, at least 12 inches in aperture, along with an astronomical camera and long exposure times. These are instruments typically found only at astronomy clubs or at semi-professional and professional observatories.
For most of us, the most practical way is to follow live streams from professional observatories around the world, where extremely large telescopes capture and share live images of this rare interstellar visitor.
And this is where things become truly fascinating. We actually don't know what 3i I-Atlas looks like. What scientists currently have are only estimates based on its brightness and how it reflects light. Its size could be around 100 to 300 meters, comparable to a skyscraper or even larger than a stadium. Its surface appears very dark, absorbing nearly all incoming light, similar to carbon-rich material found in space. There is no cometary tail, no visible gas or dust surrounding it. And its shape remains completely unknown. It could be a distorted rocky body, a jagged fragment, or something very different from anything we are familiar with. In other words, 3i ATS is like a silent shadow drifting through the solar system. We know it is there, we know where it is going, but we cannot clearly see its true nature. According to most scientists, it is a natural fragment originating from another star system. However, there are also some hypotheses surrounding it.
At present, scientists have three main scenarios to explain the origin of 3i/Atlas. And importantly, all of them are entirely natural.
Scenario 1. 3i/Atlantis is a fragment from a forming planetary system. In young star systems, where planets are still colliding and growing, violent impacts can eject rocky debris out of the system at extremely high speeds. Such a fragment can wander through interstellar space for millions of years until its Slachovna crosses our solar system. Scenario 2. 3i/Atlas was slingshotted by a giant planet. In many star systems, massive planets act like gravitational catapults. When an asteroid passes too close, their gravity can accelerate the object enough for it to escape the star system. The result is a solitary traveler drifting into interstellar space. Scenario 3, and the one many scientists currently favor, is that 3i/ATLS is the core of a dead comet. After an extremely long journey, all of its ice has completely sublimated. What remains is only a hard, dark, carbon-rich rocky core. This hypothesis fits well with what we observe. An extremely dark surface, no cometary tail, no gas activity, and a composition similar to carbon-rich asteroids in our solar system. In other words, 3I/ATALS may be the silent remnant of a comet from another star system. There is another possibility, one that sounds very scientific yet deeply unsettling. 3I/Atlas could be a fragment of a metallic planetary core. Imagine that in a distant star system, a large planet once existed. Due to a violent collision or gravitational instability, that planet was destroyed. When the crust and outer rocky layers were blown apart, the metallic core at its center, similar to Earth's core, could have been torn into large fragments and flung out of the star system. One of those core fragments could have wandered through interstellar space for millions, perhaps even billions of years, before coincidentally passing through our solar system and being designated 3I/Atlas. Some observational data make this hypothesis not entirely far-fetched. Spectral analysis indicates that the surface of 3I/Atlas is extremely dark, reflects very little light, and shows signatures consistent with materials such as iron, nickel, and carbon. These characteristics are quite similar to metallic meteorites that have been found on Earth. If this hypothesis is correct, then 3I/Atlas is not just a wandering rock. It could be a fragment of the core of a dead planet. And then we arrive at the question everyone has thought about, but very few dare to say out loud. After the Oumuamua event in 2017, the scientific community no longer discussed only rocks and ice. Some researchers, including Professor Avi Loeb of Harvard University, put forward a more audacious possibility. Could some interstellar objects be not entirely natural? This is not a conclusion, but a controversial scientific question. First, the hyperbolic trajectory is remarkably clean. Objects like Oumuamua and 3I/Atlas enter the solar system and then leave along open trajectories that are so precise that some have wondered whether this is truly just random chance. Second is Oumuamua's anomalous acceleration. As it moved away from the Sun, it experienced a slight increase in speed, despite having no cometary tail and no visible gas or ice outgassing to propel it. This behavior posed challenges for several conventional models. Third is the unusual shape. Data suggests that Oumuamua may be extremely elongated or flattened like a thin sheet, very different from the more rounded shapes of most asteroids and comets we are familiar with. And finally, there is a much bigger question. Why have we detected so few interstellar objects? If the galaxy contains countless stars and planetary systems, such wanderers should, in theory, appear far more frequently. Some have speculated that if extraterrestrial technology exists,
Most of it may not transmit signals, may not emit light, and may simply pass by in silence, just like Oumuamua.
But when viewed purely through the lens of science, the existing data tell a very ordinary story. First of all, no signals have been detected. No radio waves, no unusual infrared radiation, and no form of energy emission resembling artificial technology. 3I/Atlas is completely silent.
Second, the trajectory of 3I Atlas is fully consistent with the laws of natural physics. Although it follows a hyperbolic path, it still obeys the sun's gravity and models that astronomy understands well. There is no anomalous motion and no sign of self-correction. Third, there is nothing unusual about its chemical composition. What observations reveal is consistent with rock, ancient ice, or carbon-rich material, exactly the kind of natural matter seen in objects both within and beyond our solar system. There is no sign of artificial structure, no regular geometry, and no abnormal reflective surfaces. The way it heats up as it approaches the sun and cools down as it moves away is also completely normal. All current data indicate that this is a natural mass of material drifting through space. The truth is, we want it to be extraterrestrial, because that would be exciting. But science tells us that this is simply a rock from another star system. And that is still absolutely amazing. Carefully studying every interstellar object is important. Because if one day an actual extraterrestrial spacecraft truly passes by, we don't want to miss it. So, beyond simply gazing at a strange visitor, what do we actually learn from 3I/Atlas? First and foremost, we learn about the origins of our solar system. 3I/Atlas was most likely born in a young planetary system, where violent collisions and chaos once reigned. Very similar to our own solar system billions of years ago. By studying this object, scientists are not just looking at a distant world, but are peering back into our own past. Next is the chemistry of interstellar space. Data suggests that 3I Atlas is rich in carbon and may contain complex organic molecules. This indicates that the space between stars is far from empty, but instead contains the fundamental materials for planet formation and possibly the early conditions for life. 3I Atlas also changes how we think about the number of interstellar objects. In less than a decade, we have discovered Oumuamua, then 2I Borisov, and now 3I Atlas. There may be many such wanderers passing through the solar system every year. It's just that only now do we have the capability to detect them. And finally, there is the lesson of diversity. No two interstellar objects are alike. The galaxy creates worlds in countless different ways, and each star system leaves behind fragments that carry its own unique historical signature.
So, how do scientists study 3I Atlas? The short answer is they don't look at it in just one way. They piece together many fragments of data, like assembling an incomplete puzzle.
In space, the James Webb Space Telescope observes in the infrared to measure temperature and search for signatures of carbon or organic molecules. Hubble tracks visible light and monitors the position of 3I/Atlas over time. On the ground, extremely large instruments, such as the VLT in Chile and the ALMA array, capture very faint signals, adding details that space telescopes cannot detect. In addition, many other observatories continuously monitor it, ensuring that no change goes unnoticed.
More important is how they analyze the data. When light from 3I Atlas enters a telescope, it is split into its constituent colors. Through spectral analysis, scientists can determine whether the object is made of rock, ice, carbon, or metal. Each element leaves its own unique fingerprint in the light.
Next comes measuring its brightness over time. By tracking how 3I/Atlas brightens or fades, scientists can estimate its size and even infer its shape. If the brightness varies irregularly, it is likely that the object is not spherical, but distorted or elongated. Alongside this is the calculation of its trajectory with extreme precision. Every night, the position of 3I/Atlas is recorded, and mathematics is used to map its three-dimensional path through space. This allows scientists to be certain that it came from beyond the solar system and to predict the direction in which it will depart.
Finally, there is observation in the infrared. This is how scientists measure surface temperature and search for remaining ice or organic molecules. If there is any unusual activity, infrared observations can detect it immediately, even when other telescopes see nothing.
And then a much bigger question arises. 3I/Atlas is not just a passing object. It forces us to consider far greater questions. The star system it came from, does it still exist? Or has that star already changed or even died long before this fragment began its journey? Were there planets orbiting that star? And if so, did they ever have conditions suitable for life? If one day humanity develops the technology to launch a probe, accelerating fast enough to chase 3I/Atlas, could that journey take us back to the place where it was born? To the home of a fragment from another world? So let us remember these days. These are the fleeting moments when humanity witnesses a visitor from beyond the solar system.
From December 10th to 15, 3I/Atlas gradually approached. It was still very faint, but its trajectory clearly indicated that it was entering the most critical phase of its journey. By December 17 and 18, observatories around the world began monitoring it intensively. Large telescopes were prioritized with longer observation times, because everyone knew this opportunity would not come again. And then, December 19th, 2025, a historic day. The moment when 3I/Atlas made its closest approach to Earth. Not dangerous, no collision, but close enough for us to gather the most valuable data from an object originating in another star system.
After that, from December 20 to 31, everything happened very quickly. 3I Atlas moved away from us, fading and cooling, like a hurried farewell. As we entered January 2026 and the months that followed, it disappeared completely from human observation. No more images, no new data, only what we had time to record.
There is something truly special about 3I and Atlas. It does not care who we are, nor about politics, religion, or borders. It simply passes by, but in that brief time, it reminds us that we are part of a universe much larger than ourselves. And rocks from other stars can teach us about the origins of our own world.
In the 4.6 billion years of the solar system's existence, there have been only 3 times we know for certain that an interstellar object has passed through. And we are fortunate enough to live in an era with the technology to see them. So on the night of December 19th, even if you cannot see it with the naked eye, look up at the sky toward the constellation Leo. And remember that at that very moment, a visitor from the stars was flying by, carrying the story of a world we will never see. If you found the journey of 3I Atlas fascinating, don't forget to like, subscribe, and turn on notifications, because who knows, the 4th interstellar object could appear at any time. And when it does, we will have yet another visitor from the distant stars.